Hi there, pre-calcers. Time for the last lesson in Chapter 7, Solving Trig Equations. Here's some tips to solving these things. Obviously, just like with any equation, we like to isolate the variable or get that variable by itself. It's just that in this case, the variable will be a trig function, not just an x or a theta, but a whole trig function like cosine of x or tangent of theta. And then oftentimes we'll maybe have to use the inverse to solve, or maybe we'll be able to look on our circle chart and be able to figure out angle or angles that might be the solution. Very important piece right here. Sometimes when we're solving equations, we divide each side by a number, and we may be able to do that here, but can't recommend it because when we do that, we might lose some of our possible answers. We have an example today that will show that. Be wary of fishy solutions. In other words, remember that sine and cosine, their maximum and minimum values are range from 1 to -1. So if you ever get an answer of cosine equaling 2, you know that something's fishy about that. And then probably the trickiest part is to watch the domain. They'll talk about principal values. Here's our principal right here. Principal values essentially just mean, in our case, restricted domains. So this is kind of like what we'd seen before in Chapter 6 when we used inverse functions. The principal values for sine and tangent have to be in quadrants 1 and 4, and for cosine in quadrants 1 and 2. One positive quadrant and one negative quadrant. So keep these things in mind, and let's just get to work and try here. All right, first one is to solve the cosine of x equals -1/2 for principal values of x. So I've included a circle chart here. We see that where cosine equals -1/2, there are a couple places here. We could actually draw a little line going down here. And one of our answers, we'll just do this in degrees, one of our answers could be 120 degrees, as we can see here. And the other answer could be 240 degrees. But once again, we're kind of limited by that principal value idea here. And remember, with cosine anyway, the two quadrants we can look at are quadrant 1 and quadrant 2. So we can't use this one right here for an answer. So in this case, my official answer would be that x equals 120 degrees. That's how that principal value stuff works. So another example here. This one's a little bit trickier. This one says to solve this for principal values of theta in degrees. Now again, here we have to do a little bit of manipulation to try to solve this one correctly. I'm going to try to get the sine of theta by itself. So the first thing I'm going to do is add that square root of 3 to each side here. And after I do that, I'll get 2 sine theta equals the square root of 3. And then I'll want to divide both sides by 2. So I'll get the sine of theta equals the square root of 3 over 2. Now we know or see that there are a couple places where that occurs. Sine again is my y-coordinate. So up here at 60 degrees, and also over here at 120 degrees. But as we can see, here's that principal value idea. With sine, remember, our only answers can be in quadrants 1 and 4 down here. So that means I have to eliminate the answer that's in quadrant 2, and my answer in degrees then would have to be that theta equals 60 degrees. Okay? So far so good. Keep ratcheting up the difficulty here a bit. Now, here we have a quadratic, essentially, we're going to solve. Cosine squared minus cosine minus 2 equals 0. And notice here our domain is set for us between 0 and 2 pi. That means basically once around the circle chart. Now when we have quadratics, you may remember from a few chapters ago, We have many ways that we can solve them by graphing, completing the square, factoring, the quadratic formula. But by far, the easiest way when we have these trig functions is going to be by factoring. That's going to be our preferred way of solving these if possible. So you might remember with factoring, you always look for a common factor, and there is no common factor for all three of these terms. This is a trinomial. If we have a common factor, there has to be a common factor in each term. These two have a common factor of cosine, but not my constant term there. So when that fails to occur, then I'm going to do my two sets of parentheses like this. This is my FOIL method in reverse here, essentially. And just as if this were x squared and x, when I have cosine squared, chances are my first value here is going to be the cosine of x, because when I FOIL this out, cosine times cosine will be cosine squared. And then I have to think, well, what numbers can I multiply together to give me -2? And I'd say it's probably going to be -2 and +1. And I know that because here's that negative sign right here. That's that middle term has to be negative. So this is the correct factorization. You could FOIL this out to see if it worked. This is right. Now I'm not done yet, because now I have two groupings that when multiplied together they equal 0. That means I have to set each of these pieces equal to 0. So I'll go ahead and do that, and then I'll see if I can solve each separate piece. So here I'm going to get the cosine of x equals 2. Here I'm going to get the cosine of x equals -1. Now, as we mentioned before, one of these might look a little fishy, and sure enough, it's this one right here. This can never happen. Cosine, especially just regular standard old cosine, only ranges from -1 to 1, so it can never equal 2. On the other hand, over here, I think we're okay with that one. Where on the circle chart does cosine equal -1? Well, it's over there at 180. In this case, we want to have our answers in radians, though. So it looks like my answer would be simply pi radians, and that's going to be the best I can do in this particular case. So there's the case where factoring works to help solve an equation like that. Is probably the nastiest one there, just like this nasty guy here, nasty looking guy. How can we solve this? Notice it says for all real values of x, not just some. So, and the other complicating issue we have here is, notice now we have two different functions. We have both sine and cosine, and also the sine one is not just sine of x, but it's a sine of 2x. That's one of those double angle formulas. So right away we probably want to make a substitution for this right away if we can. And you might remember that a formula for the sine of 2x is 2 sine x cosine x. So I'm going to substitute that in there right away. Minus the cosine of x equals 0, like that. Now you might be tempted when you see a problem like this, you might say, well, could I just divide everything by cosine? Wouldn't that work out nicely? It might, but once again, that's a case where you might lose some potential solutions. So what I'm going to do is I'm going to see if I can factor this once again. And again, in this case, this is the first time I have a common factor in both of these terms. Cosine is termed a common factor. So I'm going to pull out that cosine of x, factor that out if you will, and I'm left then with 2 sine x minus 1 equals 0. And so again, now when I have two chunks or two things that are multiplied together to equal 0, I'm going to set each part equal to 0. So cosine of x equals 0, or 2 sine of x minus 1 equals 0. And I can simplify this one a little bit. This is going to be 2 sine of x equals 1, or the sine of x equals 1/2. Alright, so this is more of a general solution. I got to come up with that answer a little bit better here. So if you think on the circle chart, where does the cosine ever equal 0? Well, certainly at 90 degrees is where cosine equals 0. Cosine, of course, is your x values. That's going to be at pi over 2. And the other place where cosine equals 0 is 3 pi over 2. Now, how do I represent that, though, as a general solution? Well, every pi units, then, it's going to repeat itself. I'll just say plus pi k here. And that would actually account for this 3 pi over 2 as well. So every 180 degrees, so at 90 and 270 and then back to that same 90 again, that should take care of that situation there. I'm going to erase that. So that looks good for this particular sign there, pi over 2 plus multiples of that every pi units. Now what about when does sine equal 1/2? Well, sine equals 1/2 at 30 degrees, but once again in this case that's going to be pi over 6. And is there another place where sine equals 1/2? Well, yes. I'm going to add 2 pi to this because every time I come back around to that spot it's going to be 1/2. There's another place where sine equals 1/2. That's over at 150 degrees or 5 pi over 6. So I'm going to use that as well. 5 pi over 6 plus 2 pi k again. I realize that this is a little confusing when you have this general solution here, but just think that, yeah, to get back around on your circle chart to those particular values, you're going to have to add 2 pi in this case, where in the first example, the first part of this problem, you really just had to enter pi. All right, thanks for watching, everybody. We'll continue to work on these in class, and we'll see you then. Bye now.